We are going to pick up where we left off on Tuesday. We're going to now look at how we are going to apply inverses in order to solve systems of equations using matrices. So before you've done elimination method, substitution method, now we're going to look at how to solve them using systems. The process we're going to follow is we're going to set up a 2 by 2 matrix with the coefficients. So really what we're going to do is we're going to set up a matrix equation first. And so we're going to set our coefficients in a matrix. And then we're going to set our variables as a column in a matrix. And then we're going to equal the solution matrix, the numbers that are in the equation. And so that's a matrix equation. And so I know this is going to be required when it comes to our test, is setting up your matrix equation first. Then from there is we take the inverse of this coefficient matrix. It's kind of like solving an equation. Is if I have 2x equals 8, you know divide both sides by 2, well division is the inverse operation. So we're going to find the inverse of this coefficient matrix, and that's going to allow us to solve the equation, just like we do over here. So we learned how to find the inverse before, and then we're going to do left multiplication with the answer matrix. So let's set it up first. 2x minus 4y equals 8, x plus 5y equals 2. So the first thing I'm going to do is I'm going to translate it. I'm going to take this equation and I'm going to set up my coefficient matrix first. 2, -4, 1, 5. Then I'm going to set up my variable matrix, which in this case are x and y, equals the answer matrix, the solution matrix, which in this case we're told 8 and 2. And so this is our matrix equation. Very simple to write down. It's expected that you know how to translate from systems into matrix equations. And now your job is to apply everything we learned previously on Tuesday. Is we're first going to find the inverse of this matrix. So we're going to take this coefficient matrix and we're going to find the inverse of it. And so we learned before, the first thing we want to do with that is we want to find the determinant. So our determinant would be 2 times 5, which is 10, minus 1 times -4, which is really adding 4. 10 minus -4, 10 plus 4 gives me a determinant of 14. And we take 1 over our 14, and we do scalar multiplication in this case, where A and D trade spots, so the 5 is here, the 2 is here. B and C change signs, and so now instead of -4, I have +4. Instead of +1, I have -1. And so when we do the scalar multiplication, the 1 gets multiplied to everything. 1 to 5, 1 to 4, 1 to -1, 1 to 2, and everything just gets put over the 14. So I get 5 over 14, I get 4 over 14, I get -1 over 14, and I get 2 over 14. And of course, 2 of those can be simplified. I have 5 over 14, I have 2 over 7, I have -1 over 14, and I have 1 over 7. This is our inverse matrix. That's the key. So we first set up our coefficient matrix, our variable matrix, our answer matrix. We found the inverse of our coefficient matrix. So now we're almost done. We're going to take the inverse matrix and we're going to multiply it by our answer matrix. So I take my inverse and I multiply it by my answer matrix, my solution matrix. And it has to be left multiplication just like we did with transformations. So I'm going to take the 5/14, the 2/7, the negative 1/14th, and the 1/7, and I'm going to multiply that by 8, 2 matrix. So let's perform the multiplication. We do row times columns. So the 5/14 gets multiplied to the 8 plus the 2/7 gets multiplied to the 2. And we can do some fun old addition and subtraction with matrices. And so here I have 40/14, which in that case, if I have 40/14, I'm going to have 27s. I have plus 4/7. So I get 24 sevens. Not bad. So now I'm going to take and do the second row. And it's going to be distributed to the 8 and 2 as well. So I have negative 1/14 times 8 plus 1/7 times 2. In that case, I get negative 8/14, which becomes negative 4/7, plus 1 times 2, 2/7. So I get negative 2 sevens. Now those are your values for x and y. And so we're going to set them up as a matrix equals x, y as a matrix. A little sloppy, we can tidy it up if we need to. So you can see all the steps. So all on one screen, here we go. We did matrix equation, coefficient matrix times variable matrix equals our answer matrix. We then took and found the inverse of our coefficient matrix. And we used that inverse and did left multiplication with the answers, the solutions, and it gave us the values of x and y. And this is the final format for the answers for the system of equations. So what's nice is if we were doing substitution elimination, you'd have to work a lot with the fractions. And in this case, working with the fractions was not too hard here. Let's try another one. So first up is always your matrix equation. So I have 2, negative 3, 1, 5. I then have the variable matrix. Again, we're using x and y. Equals our answer matrix, which is 7, 5. So there's the first step. It's going to be required on the quiz that you write the matrix equation. And now I'm going to find the inverse. So I'm going to take my coefficient matrix and I want to find what is the inverse of this matrix. And to do this, we first find the determinant. So the determinant here would again be 2 times 5, which is 10, minus 1 times negative 3, so minus and negative is really addition. So my determinant is 13. So to find the inverse, I would do 1 over that determinant, which is 13, scalar multiplication, where A and D trade spots. So the 5 goes here, the 2 goes here. B and C change signs, so it's going to become a positive 3, and it's going to become a negative 1. And then we do scalar multiplication. So 1 goes to 5, 1 goes to 3, 1 goes to negative 1, 1 goes to 2. That's actually not bad because there's not going to be any simplifying there. I'm going to have 5 over 13. I'm going to have 3 over 13, negative 1 over 13, and 2 over 13. And that is my inverse matrix. Sweet. Now I can take that matrix and I'm going to multiply it by my answer matrix. And again, because I'm special, I have the ability to take my work, shrink it down, move it to the side, and make more room for what I'm trying to do. So I'm going to take this inverse matrix, and again, I'll use some nice little skills of copy paste. And we're going to multiply it by our answer matrix, which is 7, 5. So in this case, row to column, the 5 over 13 gets multiplied to the 7, plus 3 over 13 gets multiplied to the 5. That's going to give me 35 over 13 plus 15 over 13, which in this case gives me 50 over 13. And I repeat it with the second row. I have negative 1 over 13 times 7 plus 2 over 13 times 5. It gives me negative 7 over 13 plus 10 over 13, which gives me 3 over 13. And those represent your values for x and y. So this equals the variable matrix x, y. And that is our final answer. Our x value is 50 over 13. Our y value is 3 over 13. Same setup every single time. We're going to take our coefficient matrix, set it up with our variable matrix equal to our answer matrix, find the inverse, and then multiply those together. So now we'll do one last one by hand. That's not bad, and we'll set it up. This time, hopefully I can have enough room. And I will do my coefficient matrix, 4, 2, negative 2, 1. Do the variable matrix, x, y, equals our answer matrix, which in this case is 1, 10. All right, so we'll speed things up a little bit, and we'll just find right away the inverse of this. So I have to find the determinant first. So 4 times 1 is 4. Negative 2 times 2 is negative 4. So minus negative really is addition. So I get 8. So for my inverse, I'm going to have 1 over 8, scalar multiplication. A and D trade spots, 1 and 4 will switch. Change the sign of B, so this one becomes negative 2. Change the sign of C, this one becomes positive 2. Now, right away, I know there's going to be a lot of simplifying here because I see a lot of even numbers. So I'm going to do 1 times 1, which is 1, and put it over 8. I'm going to do 1 times negative 2, which is negative 2, put it over 8, I get negative 1/4. 1 times 2 is 2, put it over 8, I get 1/4. 1 times 4 is 4, put it over 8, I get 1/2. Like I said, we're going to move a little bit faster, mix the simplifying into the process as well. And so that's my inverse. I'm going to take this matrix and I am going to do multiplication with my answer matrix, which is 1, 10. So I'm going to multiply these together and we will end up with the values of the variables. Row to column. So 1/8 is going to go to the 1, negative 1/4 is going to go to the 10. So I have 1/8 times 1 plus negative 1/4 times 10. That's going to give me 1/8. I have minus 10/4, which is going to be negative 5/2. Doing some quick calculations, 1/8 minus 5/2 is going to give me negative 19/8. Again, you just use your calculator. And we're going to then do the next one. I'm going to have 1/4 times 10, sorry, 1/4 times 1, and then plus 1/2 times 10. And I'm going to get 1/4, 10/2 is 5, so I have 5 and a 4th, which is 21/4. So my x, y is equal to negative 19 over 8 and 21/4. And that is my answer. So here's what we have. I did the calculations fast when we were doing the multiplication because, guys, this is just arithmetic with fractions. If you can't find the common denominator and get the answers fast, you have a calculator that has the wonderful ability to work with fractions. So I went right to the answers, and there we go. This is how we solve systems by hand. You are expected to do the steps exactly the same way shown, which is set up your matrix equation, find the inverse, show the multiplication, get your answers. Now, the reason why you're expected to show the work exactly is so one, we know you understand the process, and two, because your calculators are amazing. Is your calculators can solve a system of equations in, well, it depends how long it takes you to type it in, but really it could be seconds. So the idea is, how do you type it into your calculator? And it's very similar to the process we use to find our answer. We took our inverse matrix and we multiplied by our answer matrix. Well, the inverse matrix, if you look at the notation that we worked with in the beginning of the lesson, is your coefficient matrix, 3, 4, 1, -2, 4, 1, raised to the negative first power. I mean, even look at your homework and all the problems that dealt with find the inverse, it had this notation. That's inverse. So this represents the inverse matrix. And we are going to multiply that by our answer matrix, our solution matrix, which in this case is the 5, 7, 10. So 5, 7, 10. That should give us the values of our variables, x, y, z. And that's it. I mean, we are going to type this in our calculators, and I'd say about 95% of you could probably type it in exactly the way it's written on the screen. And then the other 5%, well, we're going to have you guys do it a little bit differently. So we're going to now switch over to the other video where we are going to look at how to, we're just going to keep this video and show how to use the 84. So I'll pull up my calculator, I'll slide this over. So I'm going to type this into my calculator. Now here's the good news. Like I said, I really think about 95% of you can use this. Is the updated calculators for the 84s has a math type system. And if you hit this alpha button, you hit the green button in the calculator, and then hit zoom, a lot of you will have a matrix menu pop up. Now, unfortunately, I have the most updated version, which is annoying because they're in columns. Some of them will be in rows. I prefer that one. And so you're going to choose the rows and columns you want. So again, where am I? I second quit. I'm going to hit alpha, the green button, F3, which is zoom. Those are your special typing features in your calculator. So I'm going to hit the up arrow, and I'm going to go to 3 rows, hit the right arrow, go to 3 columns, and again, no matter what you do, you just horizontal, same thing, grab 3 rows, grab 3 columns, go down to OK, hit enter, bam, a 3x3 matrix on your calculator screen. Technology is amazing. And you can type in 1, 1, 3, 3, 4, 1, and then -2, 4, 1. And that is your coefficient matrix. But what we want to do is we want to take that coefficient matrix and we want to raise it to the negative first power. And that button is located right below your math. So if I look at my math button, go right below it, there's your negative first power. And so here is what our screens look like so far. There is your inverse. So wait a minute, that means your calculator has the ability to find the inverse of even a 2x2 matrix and a 3x3, a 4x4. So this is how you would find the inverse. And if I wanted to, I would just hit the math button, fraction, don't do this part. Now hit enter. There's the inverse matrix of the 3x3 matrix. It does it for me. And the reason why I hit fraction is because we noticed that most of our inverses have fractions in them. So I'll hit second, enter, pull it back up, delete the fraction part. So we're back to the beginning of our inverse matrix. I want to multiply by my solution matrix. So again, I'm going to hit alpha, zoom, but now I have only 3 rows, but 1 column. So a 3x1, hit some other button there. So let's try that again. So alpha, zoom, 3x1, hit OK. That's better. 5, 7, 10. Now we noticed that most of our answers were fractions. So you don't have to do this when you do it at the end, but I'm always doing it in the beginning. I've noticed a lot of ours are fractions, so I'm going to hit the math fraction button on the calculator just in case we get fractions. I don't know yet, but I'll hit math fraction just to be safe in case they happen to be fractions. Oh, good, they are. So I'm going to type in, write in -3/5, 104 over 55, and 68 over 55. And there is exactly what I have written on my screen. 113, 341, -241, raise the negative first power, 5, 7, 10, and there's the values. So your calculator can do all the work for you. Now, if you do not have the wonderful, wonderful, wonderful feature of Alpha Zoom, where you can pick your matrices, well, there's another video you're going to have to watch. And for you guys, it's if you have a TI 83, you have to use the old technique, which I had used when I was in school. And if you have the Inspires, there's a video as well that is going to be linked up underneath this one, that when everyone's working on the assignment, we can play that video for you with the Inspires and the 83s and how to use your calculators. But it's a very simple technique. Alpha Zoom, pick your dimensions, negative first power, there's your inverse, alpha zoom, pick the dimensions, and again, so many times we have dealt with fractions, I always put math fraction at the end. So that's all for this lesson. We've dealt with everything else before with the matrices, and we move on. So your job is to work on finishing the homework, and then you are given the review worksheet for the quiz, which is going to be on Monday still. So you will look at the answer keys online over the weekend, come in for office hours on Monday, and ask any questions. And if you have the TI Inspire or the TI 83, please watch the videos while everyone else is working underneath this one on the Google Doc to see how to use your calculator for matrices.